We have Rasheed's candy bars here, and he handed out 2/3 of his chocolate and 3/5 of his toffee packages, or candy bars rather. And we know that he buys them in packages of 2, which ends up not really being too relevant here, but it is important to think about. So statement 1, can we determine how many packages of chocolate bars Rasheed bought based on the fact that he bought 1 fewer packages of chocolate than he did toffee? Well, that means the number of chocolate packages plus 1 would equal the number of toffee packages. For example, if he bought 5 chocolate, he would have bought 6 toffee, because 5 is 1 less than T and 1 less than 6. And so 5 plus 1 equals 6. The formula ties out. But this could be any number of scenarios. He could have 1 chocolate and 2 toffee, or 2 chocolate and 3 toffee. So it's clearly insufficient. I can't tell how many he bought based on statement 1. Statement 2 is a little more interesting. So statement 2 says he handed out the same number of each candy bar, and we already knew that he handed out 2/3 chocolate and 3/5 of his toffee, which means 2/3 of C, if C represents the number of chocolate packages he bought, and 3/5 of T are equal to each other. And if we look at these two sides of the equation here, we can multiply both sides by 3 to get 2C equals 9/5 T, and then multiply both sides by 5 to get 10C equals 9T. And now we have a ratio. And what's confusing about ratios is the ratio of C to T is actually 9 to 10, because if I plug 9 in for C, I get 90 is equal to 9 times 10. So T is 10 when C is 9, and that's why the ratio is always the opposite of what it looks like when you have an equal sign in the middle. So we have 9 to 10 ratio, and we can think of that as 9x to 10x, because I don't know if it's literally 9 to 10 or if it's 18 to 20, where the x would be equal to 2. And if you need a refresher on ratios, check out our course and you will see the ratio video. It's very helpful in terms of understanding this, and the GMAT definitely likes to mess around with ratios, so it's important to think about using these multipliers. So we have 18, it could be 18 versus 20, it could be 90 versus 100, right? Could be anything where we have a 9 to 10 ratio. I don't know anything about the hard numbers. That's why we look at it as 9x to 10x. Now, if I know that the difference between C, which is 9x, and T, which is 10x, is 1, then that means that 1 is equal to x. And that means that the ratio must have literally been 9 to 10, because I can plug 1 in place of the x, and it's 9 times 1, 10 times 1, 9 to 10, meaning I purchased 9 chocolate bars and 10 toffee bars, and together these statements actually are sufficient. So answer choice C, neither of them on their own, but together they create a sufficient